In this video, we're going to look at the cosine rule. It's also like the sine rule in that we can use it to find unknown side lengths and unknown angles from any triangle you like. It doesn't have to be a right angle triangle. And we've got it written down here, and we've got it written in two different ways. They're completely equivalent. You might be able to, if you wanted to rearrange from, say, this one to get this one, and it probably wouldn't be too hard for you. Now, the reason we've got it written in two different ways is, well, one of them is going to be a lot easier to find, say, an unknown side length. So say you wanted to find side length A. This way is going to save you a lot of trouble in terms of doing the algebra. Whereas writing it this way, if you wanted to find an angle, you could use this way and it wouldn't be as much algebra for you. Now, here we've got them, in terms of little a and in terms of cos of big A. But, you could rewrite this with different orders of this. You just have to keep the relative stuff the same, if that makes sense to you. So, for example, if I wanted to find little b, if I had a b squared equals, well, then wherever I had things to do with a, I'd have to replace with b. So, for example, this would become a squared, this would become a, and this would become cos of b. So whichever one you're finding, you can kind of see how it's a bit related, perhaps. So say if I'm finding the angle A, the side length little a, well then the cos is going to be its angle, and then you've got the other two sides squared, added up, and in front of the cos of the angle you've got the minus 2 times the other two sides. And you've just got to keep that consistent. We'll see a bit more of how that works when we do some examples in the next video. Let's just go on and have a look at the proof. And just we've got the two situations where you can use this rule, where it's a good idea to use it anyway. And like with the sine rule, I don't keep these in my head. It's just a matter of kind of, as we practice, we get used to trying things out and saying, oh yeah, this is probably going to be one where I could use the cosine rule effectively. So, in terms of a proof, I'm just going to run you through this relatively quickly. If you wanted to, you could pause the video and kind of run it through yourself, but it's flowed in a similar way of the sine rule one. So like with the sine rule one, we're just starting with a triangle that doesn't have any right angles in it, yeah? So we've got triangle ABC, just kind of redrawn it up there without any of the annotations. And then what we've done is we've cut it down here to make some right angle triangles. So we've made two separate ones, right? Where this bit is x, right? So from A to D, where we've cut it, is x, and the whole thing is c, right? So anyway, let's just go through the proof now that we see how it's kind of been set up for us. So cos of A, because of this angle A, well, it's adjacent over hypotenuse. The adjacent is x, hypotenuse is b, opposite the right angle. If you rearrange that for x, well, you've got to times both sides by b, you get x equals b cos of A. Now, if we use Pythagoras' theorem on the two right angle triangles we've created, well, for this smaller one, well, b squared, the hypotenuse, is equal to x squared plus h squared, the height of the triangle. And for the other one, it's a bit more complicated, but perhaps not too bad. You might be able to realize that this side length for the triangle, or for the side length b to d, is just all of c, take away this little bit x, right? So then that side length is c minus x all squared plus h squared is equal to a squared, the hypotenuse, right? In terms of doing the rest of the proof, it's just a matter of expanding out this second equation. So if I were to get equation 2 there and expand it, I'd get a squared is equal to, well, the first term would be c squared, take away 2xc, right, plus x squared plus h squared. And now when I look at this, I go, all right, well, x squared plus h squared, in my first equation, that's just b squared, isn't it? I can replace that. I've got a squared equal to c squared. And then I'm just going to take this bit, put it here, plus b squared. Yeah? With this last bit, the 2 times xc, we just write it as 2 times c and replace the x with what x is up here, b cos A. We start to get something looking very similar to what we had on the other slide. So if you just rearrange this, a squared is equal to b squared plus c squared. I'm allowed to, the order of those two things doesn't matter, right? And then just writing this with my variables in alphabetical order. And I get exactly what I had on the last slide, right? So there it is. Now, so yeah, hopefully that's not so bad. And you've got a bit of a feel of how this proof works. There we go. Let's leave it there for now.